Hello, grade 8. How are you? Now I will revise with you the lessons that are included in our quiz. I will start with chapter 4 in geometry. I will make a revision for the first 4 lessons. Then I will make another revision for the second two lessons and the lessons in the algebra. Let's start now with chapter 4. The chapter 4, it's talking about congruence. Now, what's the meaning of congruence? And is the congruent only on triangles, or it could be on pentagon, hexagon, any polygon? Yes, the congruence, it will happen in any closed shape. Now, the congruent figures have the same size and shape. If I said that these two shapes are congruent, that's mean it must have the same size and the same shape. Both of them, same size and same shape. So, and if I want to talk about a congruent figures, I need to write all the congruent corresponding parts, all the corresponding elements, and check if these corresponding elements, if all of them are congruent, so the two shapes will be congruent. So I told you, if I want to decide if these two shapes are congruent, I have to check all the elements inside this shape are congruent. How can I decide if they are congruent? By writing all the elements, the corresponding elements. So the first thing I need to know, how can I write the corresponding elements? The corresponding elements, it could be sides and angles. Now, look at this shape here. In this one here, we have, as you see, we have a triangle. In this one, the first triangle is A, B, C, and the second one, it is X, Y, and Z. Look how I will say A, B, C, congruent with X, Y, and Z. And as I told you, this sign, its mean is congruent too. So from this one, I have seen now that AB, side AB, is congruent to XZ, and BC is congruent to YZ, and AC is congruent to XY. So if I have the shapes, and these shapes are drawing with the same direction, I will say that they are congruent. But sometimes they told me that triangle ABC with XYZ without drawing. So how can I know which sides are congruent and which angles are congruent? Look here now. If I have A, B, C, I have to check it with X, Y, and Z. Both of them are congruent. If they are congruent, I ask you to write all the corresponding elements. What you have to do? The first step, you have to list A, B, C, and under it you have to write X, Y, and Z. Then, if I asked you what is the corresponding angle for an angle A, you have to say like this. You will say angle A is corresponding with an angle X, and so on. They are under each other. Order them, line up them under each other. So the angle B now, it will be congruent with angle Y, and an angle C, it will be congruent with an angle Z. With an angle Z. Just write them under each other. This is for the angles. Now what about the sides? How can I write the corresponding sides? Now, let's see how. I asked you as an example to write me or to tell me what is the corresponding sides oh, I'm sorry, AB is correspond to, or what is the sides that corresponds to AB? What you have to do, you will say AB, line segment AB is corresponds to, here you have now AB, under it you have XY. So you will say line segment AB is corresponding to XY. They are under each other. If I'm asking you now, line segment BC, what is the line segment that is corresponds to BC? What you have to do? You will have the same steps. You will make like this. Here is BC. So the two letters under it is YZ. So you will say now line segment YZ. But if I told you now, what is the line segment that corresponds to C, then B, you will say X, then Y. C, B, it will be X, Y. So BC, it corresponds, BC is correspond to YZ, but CB is corresponds to ZY. CB is corresponds to ZY. Now, what if I ask you now, what is the corresponding sides? Sorry, what is now the corresponding? So BA. What is the line segments that corresponds to BA? You will say, first you will make a square around them. So BA, so it will be YX. So because of that, you will say BA is corresponds to, corresponds to YX. Now, if I'm asking you now, CA, where is C? Here now, CA. You will say now, CA is corresponds, to ZX. So you will say now that CA corresponds to ZX. Now look at this example here. In this example, he told me that ABCD corresponds to EFGH. I want you now, since they are corresponding, they are congruent, write all the corresponding elements. So you will say AB. Now look here, AB. So EF. Here I told you, if two shapes are congruent, they have the same size and same shape. So these are the same, but they are flipped. Yeah, it means that they are like this. A, B, C, D, and the second one was like this, but its name is E, F, G, H. Now, before that, I want something that if you want to name the shape, you have to name its vertices. And to name its vertices, you have to move clockwise or counterclockwise. That's if I start now A, B, C, D. So look here, look here now how will I move? I will move with this direction. We will say it's clockwise. Since I was moving in the first shape clockwise, so I must move in the second shape with the same clockwise, not counterclockwise. And since it says A, B, C, D. So the second one, it will be E, F, G, and H. This is to name any shape. I need to name each vertex on it. To name the vertices, you have to choose a letters. Then after that, you have to make one direction, or to choose one direction to write the letters of the vertices. Now back. So here we have A, B, C, D, and it's congruent with E, F, G, H. I want you now to know, if I ask you what is the size that corresponds to AB, you will tell me it is EF. Look here, AB, EF. Now, if I'm asking you about BC, you will say that BC with FG. And F, no. If I'm asking you now about DC, where's DC? D, then C. So it's correspond now. Here we have D, C. So it's correspond now with H, G. Be careful. I say D, then C. So it will be H, then G. These elements I can, or these statements, these corresponding statements, I can write them from the shape, and also from the letters of the shapes. Like, look here, AB with EF, CD with GH, BC with FG, and also angle A with angle E, angle B with angle F, angle C with angle G, and so on. Now, segments that are congruent have the same length? Yes, we say that. Why? Because if we have two shapes that are congruent, so they have the same size and same shape. The second one, polygons that are congruent have the same shape but are not always have the same size. False. The third one, incongruent figures corresponding angles have the same measure. Yes. Now, here now complete the following statements. Given that triangle FGH is congruent with the triangle WAX, so the line segment GH is corresponds to what? I will write here FGH, and under it I will write WAX. So GH is corresponds to AX. So I will say now the line segment GH is corresponds to AX, and angle W corresponds to angle F. Look at now the second one here. B, the line, the shape BIKE with PATH. He told me now angle T, or he asked me now angle T. Which angle is corresponds to angle T? Look at the letters here. It was K. Now, if I say now THPA, look at me here. THPA. Ask me now what the corresponding sides will be. If it's I have now PATH, and under it we have BIKE. Now, if you put at the first TH and then you put PA at the last, yes, that's it, THPA. So I write them in the opposite order. So it will be here, since TH is under, from here, since now TH is under KE, so I will pick KE here and BI here. So I will say now that THPA corresponds to KEBI. So if I want to prove that these two shapes are congruent, I must write all the corresponding elements. If all of the corresponding elements are congruent, I will say that the two shapes are congruent. So if I need to prove that the t-squares or two rectangles are congruent, how many statements should I write? As I told you before, to write or to know how many statements should I need to check the congruent of the two shapes, I have to use this formula, 2n. That's me. If I ask you as an example to prove that if these two rectangles are congruent, you have to write the four sides with the four angles. So you will have 8 statements. From where we bring these 8 statements, all of us know that we have 4 sides for the rectangle. If you multiply it by 2, you will get 8. That's why we need 8 statements to prove that these two shapes are congruent. Another example. If you have two hexagons, and I ask you now how many statements you have to write to prove that these two hexagons are congruent. I will use this formula, this rule, 2n. 2n, that is mean how many sides for the hexagon? Hexagon, it has 6 times 2. So I need to write 12 statements, 12 corresponding statements that to check that these two hexagons are congruent. So if I'm talking about square, rectangle, any side that has any shape that has 4 sides, the number of sides are 4 or more, I need to write all the elements. But the triangle is a special case. In the triangle, I didn't need to write all the 6 elements. I can write, if I write 3 of them, and these 3 are congruent, so I can say now the 2 triangles are congruent. So to prove 2 triangles congruent, should I write all the corresponding parts are congruent. Now, today now I will talk about these two postulates, these 3 postulates with one theorem, and all of these postulates or theorem are used in any triangle. The first thing, I cannot use it in square, rectangle, hexagon, pentagon, and so on. It just used rectangles, triangles. And these 4 are used in any triangle. And as you remember, we talked in lesson 6 about hypotenuse leg, HL. This HL, it's used only in right triangle. So the right triangle, if I want to prove the right triangle, I can use SSS, SAS, ASA, and AAS, and HL. All of these 5 theorems or postulates I can use to prove that these 2 right triangles are congruent. But if I'm talking about isosceles or equilateral or an acute triangle, or an obtuse triangle, I use only these four postulates or triangle. So now what are these postulates? These postulates or this theorem that help me to prove that these two triangles are congruent. The first one, S, S, S. S, it means side. So it will be side, side, side. That's mean if I have now two triangles, sorry, and he told me that told me that this side is congruent with this side, and this side is congruent with this one, and this one are congruent with this one. If all the sides, side, side, sides, if all the sides are congruent, so I will say that these two triangles are congruent by S, S, S. And sometimes we have a side, angle side. What does it mean? From here, S, A, S. That's mean an angle is included between the two sides. If it is A is between them, that means S is, the angle is within these two sides or between these two sides or included between these two sides. What does it mean? That means if I have now this triangle and this triangle here, and he told me that this side is congruent with this side, and this side is congruent with this side, and this angle is congruent with this angle. I will come here now. Side, side, another side, and another side. And I will check that. Where's the angle? It is here. Since the angle is included between these two sides, so I can use SAS. The angle must be included between these two sides. If it's not included, as an example, if I told you that here is the angle. Okay, I have two sides and one angle. But my question is, this angle is included between these two sides? No, so I will not use SAS, and these two triangles are not congruent. The first and the second one, as you see here, the letter S is repeated 2 times. So if you see two sides are congruent, that's mean if you see, so the first one and the second one, as you see, a letter S is repeated 2 times. That's mean if I'm writing a proof and I see that I have two sides are congruent, I have to check. May I need another side, so I will use SSS, or I need another angle, so I will use SAS. And be careful, the angle A must be included between the two sides. The third and the fourth one, as we see here, we have two angles are repeated. Not two sides like the first and the second one. Here I say angle, side, angle, or angle, angle, side. The first one, it's a from name, A, S, A. That means the side must be included between the two angles. And the last one, since S is outside the angles, that means I need two angles and the sides, but the side here can be not included. It will be out of these two angles. As an example, if you have this triangle and this triangle, and we have angle, 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 for these two angles, if the side is between them, if the side is included, I will say now that I used ASA. But if the side is not included, if the side is here as an example, so I have A, S, A, S, which is this theorem, angle, angle, side. So for any type of triangle, I didn't need to write the 6 elements as we did in the hexagon, in the square, and so on. I just need to write 3 corresponding elements. If these corresponding elements, or if these 3 corresponding elements are congruent, so congruent, yes, I can say now these shapes are congruent. So be careful the meaning of a included angle or including side. In triangle PAD, triangle, here we have a triangle. Its name is PAD. The given angle is included between which 2 sides? He asking me about angle P. Angle P is included between which 2 sides? It's included between DP, DP, and AP. What about angle D? For an angle D now. Angle D is included between AD and PD. Now, someone teacher, if I write DA, yes, if you write DA, but you be careful, you have to write now DP. You are going from right to left, so here also from right to left. So if you write DA, you have to say that DA is the angle D is included between DA and DP.